The next guy in our story is John Dalton, who lived around 1800, give or take 40 years. And he didn't start his scientific career as a chemist. Instead, he was a meteorologist. And as the story goes, Dalton was looking at a puddle on the ground and watched it evaporate. He must not have had much else to do. And he thought that he was wondering where the water actually went when it evaporated. Because if air was a continuous substance, which is what our old Greek friend Aristotle would say, then there couldn't be any place for the water to go. Instead, Dalton thought, wait a minute, if air is made up of particles flying through empty space, then particles of water could also occupy that empty space between the atoms or molecules in the air. And that got him started on a more modern investigation, a more thorough investigation, an experimental investigation of Democritus' theory of atoms. So he basically did systematic chemical experiments, combining chemicals, looking at the results, and developed the first modern theory of atomic chemistry. But you'll notice that in his theory, these statements are very similar to what Democritus said, but now they have a more rigorous scientific backing. And of course, you know what the pencil icon means. You're going to have to record these in your notebook. So here they are. Dalton believed that all matter consisted of, again, invisible particles, and he called them atoms, and he thought they were separated by the void, no difference from Democritus. He also thought that atoms were indestructible and lasted forever, which is still true with the exception of nuclear reactions, which we will save for the end of the year. That atoms are solid, but they are invisible. Right? Again, too small to be seen. And he also recognized that the unique thing about an element is that every atom in an element is identical. Again, what we just talked about in our matter unit. And he thought that atoms would combine to make the compounds and are rearranged in reactions. And he also thought that atoms would be combined in whole number ratios, 3 of one, 2 of another, and that they had different shapes and fit together like puzzle pieces. So these 5 statements are the core of Dalton's theory of the atom and his theory about chemistry. And it turns out that it's still valid today with some minor exceptions, such as the nuclear reactions that can actually destroy or change an atom. But apart from that, he got the story correct.